Okay, so last time we talked about classifying differential equations and the order of those, depending on the derivative. We talked about independent and dependent variables, and you got to see a variety of those things for each of those problems. Today, we want to begin thinking about could something be a solution to a differential equation? So you really have to change your mindset about things that you consider to be solutions. We're used to solving an equation and getting x equal 5 or something of that nature. But for a differential equation, I typically get a solution that's a function. So it may have x's and y's in it, and that's okay. We're trying to see, does that satisfy the given differential equation? So if you look on your handout at number 1, I've been given a function, and then I want to know, does that function satisfy this differential equation? So this is actually the problem that I'm working, but to do that, I need x double prime in this case and x. Of course, I've been given x, so let me find its first derivative. My camera keeps focusing. Bear with me one moment. Maybe it'll stay there. I don't know. So I need to ultimately get the second derivative of that function. Sorry for the technological difficulty. I want to be lined up where you can see. So here we go, x prime. I'm differentiating the cosine function. The derivative of cosine is negative sine, and the derivative of sine is cosine. So that's what the first derivative looks like. Unfortunately, I don't need the first derivative for that problem. I need the second derivative. Let me shift this camera over. There we go. Maybe that'll work. The second derivative. So I'm differentiating sine. The derivative of sine is still cosine. And the derivative of cosine is negative sine. So negative sine times negative 3 gives me my positive 3. So you know the game we're going to play now is I'm going to substitute all of those things in. I'm going to plug this in for x double prime. I'm going to plug in all of this for x prime, or rather, sorry, I'm not going to use that at all, am I? I'm going to plug all of this in for x. And then if it makes that a true statement, if it makes it be 0, great, it's a solution. If not, not a solution. So x double prime, we have negative 2 cosine t plus 3 sine t plus the original function, which is 2 cosine t minus 3 sine t. And I want to know, is that really indeed a 0? Sorry for all the camera issues. I can't get it where you can see, but I'll try to keep moving it around. So it looks like a negative 2 cosine and positive 2 cosine go away. Positive 3 sine and negative 3 go away. So that makes that be a true statement. And so you may see on the handout that I did 3 dots, which means therefore that a function is indeed a solution to that equation. So that's what we're on the lookout for today. Is something a solution or not? And there's not just a handful of these to check to see, are they solutions? So I'm going to do just a couple of them. The derivatives is what's going to catch you here, taking those derivatives depending on the function. So you'll want to be sure and review any of your calculus rules that you may need to. Look at number 4. Have a function theta that's a function of t, right? So my dependent variable here is theta. My independent variable is t. So I need a second derivative. I need a first derivative. And then I need the original function to be able to substitute into that problem. And we want to see, is it a true statement or not? So this problem deals with solving for, taking derivatives rather involving an e. All right, so on problem 4, if I differentiate theta, I'm going to use the notation that's in that problem, d theta dt. Remember, when I differentiate e to a power, we always get the e to the power piece back and then the derivative of the power. So I always get e to the 3t back times a 3 times a 2 that was already in that problem. And likewise here, I get e to the 2t back. The derivative of 2t is 2 times the negative that was in that problem. So it looks like my first derivative is 6e to the 3t minus 2e to the 2t. I need the second derivative. So I'm differentiating this function. So the derivative of that, you can go through your e to a power rules. It ends up being 18e to the 3t minus 4e to the 2t power. So I'm going to substitute both of those things into the second derivative, the first derivative, and the function in my problem. So let's do that. So the differential equation says the second derivative looks like 18e to the 3t minus 4e to the 2t. And then it's got minus theta. Well, I know what theta is. That was the original. I've actually got a couple of places to substitute that in. Times the first derivative plus 3 times the function and I'm out of room, but I want to know, does all of that equal to a negative 2e to the 2t power? Sorry again for it being off the screen. So I've got several things to do. I need to multiply or FOIL all of this out. I need to do the multiplication here. Okay, so 18e to the 3t, 4e to the 2t. So I'm going to FOIL in the middle. I'm going to FOIL and take the opposite kind of in one step. So 2e to the 3t times 6e to 3t. 2 times 6 is 12. And when I multiply like bases, I add their power. So 12e to the 6t. And I need to take the opposite of that. And now 2 times negative 2 is negative 4. That's going to make it be positive 4. E to the 5t. I'm going to multiply the inside terms. That's going to be a negative 6. That's going to make it be positive 6. E to the 5t. And then finally, negative times negative is positive. This makes it back to negative 2e to the 4t. Plus 3 times 2 is 6. And 3 times 1 is 3. And again, I want to know, does all of that equal a negative 2e to the 2t? Which means lots of things need to be able to cancel out. Let's see what's going to happen. Do I have some 6t terms? I have this. This is the only one of those that I've got. I've got some 5t terms. Let me hope I find them all. 4 and 6 is 10e to the 5t. I've got a 4t term. And I'm not going to continue to write all that out. It doesn't look like anything's going to cancel out to leave me just this term up here. So I'm out of room there, of course, as well. But therefore, this is not a solution. It's not going to give me that on the other side. All right, these are not bad problems. You want to go through number 2, 3, and then 5 and 6 for this week. And be sure those are solutions or not. There are solutions to those posted on your Canvas shell.